So this video is going to go over doing pH calculations and working with the calculator and how to do logs. But before we get started on that, we are going to talk about the scale having to do with how do we assess whether something is acidic, basic, or neutral. So again, neutral we're going to classify as a pH of 7, but then anything below 7 is going to be acidic, anything above 7 is going to be basic. And don't worry about it in terms of, is it 6.99? Is that acidic or is that basic? Or neutral, sorry. That's not really going to be something you need to worry about. So let's work some calculations together so you can see how pH plays with your calculator. So what is the pH of a solution with a hydrogen ion concentration? So again, H plus is hydrogen ion concentration of 2 times 10 to the negative 8. Is the solution acidic or basic? So again, get out your calculator so you can follow along with me. And what we're going to do is take the negative log of that number. So you're going to type in your calculator, just trying to so you can see it, negative, and hit the log button on your calculator so you get log, and then you type in 2, second function E, negative 8. So that's what it should look like on your screen. And then hit enter, and you get 6.9889, so on and so forth. So one rule you have with pH is you go off of the sig figs that are given to you. So you have 2, there is your sig fig. So when you do the pH calculation, it is digits after the decimal is where your sig figs are. If I have 1 sig fig, I'm going to have 7.7 as my final answer because I can't put it to 7. If I put it to 7, then that would be saying it's neutral as a pH of 7. And I know that it's above 7. So I know that it's basic. Okay, so you could write down basic for this solution. So that is why we do digits after the decimal, because the 1 through 14, which is our range, is based off of the log. So we do the digits after the decimal because that's going to be where we find out more information. All right, so next one on your packet is the following. Find the pH if you have an OH, a hydroxide concentration of 3.1 times 10 to the negative 4. So again, with all of these, try it in your calculator, pause the video, and see if you get the same answer as I do. So this problem, you could do one of 2 ways. You can divide this number into 10 to the negative 14th to get your H plus concentration. So usually students don't do this one. And then you take the negative log of it, you get 10.49. Again, I have 2 sig figs here, so I have 2 digits after the decimal, 2 digits after the decimal. So my answer is 10.49. Most students do it the other way. You take the negative log of the number I give you, and that's your POH. But you need to be careful. You don't stop there. And you have to remember that it is POH, so you have to subtract it from 14. So it is a basic solution because it's above 7. So the only reason I point this out to you is that's the most common mistake when you're doing these calculations is understanding, is this POH or pH? Do I have to subtract from 14 or do I not? All right, so the one calculation that you have to do a particular way is this way, where you're given the concentration of one of the ions and you have to find the concentration of the other ion. So you can't take the negative log of anything and kind of go backwards on this one. So you're always going to be dividing into 10 to the negative 14. So always think of it kind of like the calculations with frequency and wavelength. You were always dividing into the speed of light. This one, you're always dividing into 10 to the negative 14. Okay, so let me show you that on the calculator. So type in 1, second function E, and then type in negative 14. Then hit the division key, and that's where you're going to plug in the number that is given in the problem. So 3.67, second function E, and it's a negative 8. So type in a negative 8. Okay, hit enter, and you're probably going to get a really, really tiny number. So please remember on your calculator, if you hit the second function and this key, it flips back and forth. You could flip it to scientific notation and hit enter, and it will do the work for you. So you get 2.72 times 10 to the negative 7. And this one is going to be 3 sig figs because that is what's given in the problem. So this is a normal number. There's no pH in this one. So the normal number, you follow what you are given in the problem. Okay, so you have 2 other problems given. So first off, find the pH if I give you 4.6 times 10 to the negative 3. So pause the video and see if you could do this one. So you should have taken the negative log of that number and you should have gotten 2.34. Again, 4.6 is 2 sig figs, so you're going to have 2 digits after the decimal for this one. And then try this next one, and then I will help you with the following one. So find the pH if your OH concentration is 3.8 times 10 to the negative 6. So again, pause the video. All right, so this one, you could take the negative log of it, and that's going to be your POH. So that's going to be 5.42. So again, you just got to be careful about these. They're not tricky other than the fact to recognize that this number that you get out is your POH, and you have to subtract from 14 to get 8.58. Again, I have 2 sig figs, so my final answer should have 2 digits after the decimal, 2 digits after. All right, so these last calculations, I'm going to do one for you, and then you're going to try one on your own. And these are what I call backwards because you're going to be given the pH and you have to go back and find the concentration of the ion. So 4.3 pH. So what I want you to take a look at is your log button on your calculator and see the 10 to the x above it. So what we're going to do is an inverse log, essentially. So we know that pH is negative log of H plus. So I'm just going to show you where this all fits in. So 4.3 is my pH. So I'm just switching where my X is. And I have the negative log of hydrogen ion concentration, which is what I'm trying to find. So I need to move the negative over, like I would in a normal math problem. And now I need to bring the log over. Again, look at your calculator. It's going to be 10 to the negative 4.3. So in your notes, write 10 to the negative pH for these types of calculations. So whatever the pH is given, make it a negative and do 10 to that. Again, you could do 10 carat, it doesn't matter, but I'm going to show it to you on the calculator using that button. So if you hit second function log, you will get 10 carat for you to work with. Type in negative, don't forget the negative 4.3, and then type in enter. And this one comes out to be 5 times 10 to the negative 5th. Now, this one is always the goofy one. I only have 1 sig fig here because of the 4.3. So that means my final answer can only have 1 sig fig. Now, if you wrote down 5.0, I'd probably give it to you. Times 10 to the negative 5th, don't forget that. That's very important. Again, these are very tiny numbers. But if you have 1 digit after the decimal, your final answer should only have 1 digit as well. All right, so again, 10 to the negative pH is how you go backwards. So let's try, I want you to try this one on your own, and then you could check your answer with me. If I start with the pH of 5.5, what is the hydroxide concentration? So not just the H plus, again, that was what the last problem was, but what is it if it's OH? What if it is OH? Again, pause the video and then see what you come up with. All right, so probably the easiest way to do this problem is to take pH plus POH gives me 14. So I'm going to take the 5.5 and subtract it from 14 to get my POH, which is 8.5, 8.5. So then I'm going to take the negative log, or I'm going to understand that this is the POH. So this goes over here, just like pH, no different. And I'm going to take the negative log of it. I'm going to bring it to the negative and then bring it to the power of 10. Excuse me, 10 to the power of that. So again, in your calculator, you could hit second function log, and then type in negative 8.5. And you will get the answer. Now I only have 1 sig fig here, so that's why you will see my final answer is 3 times 10 to the negative 9. Again, because the 5.5, that 5 is only giving me 1 digit of significance. So that's why my final answer is 3 times 10 to the negative 9. So again, follow those rules and you could do any pH calculation that you want.